Welcome to this explainer. Look, if you're a focused learner aiming for absolute top-tier success in the Cambridge IGCSE Additional Mathematics syllabus, specifically paper 0606, you are in exactly the right place. I'm your host, and today we are going to treat your exam strategy like an architectural blueprint. We're going to master one of the most rigorously tested and honestly most feared concepts in the entire curriculum: composite function domains and ranges. Think of this as your ultimate foundation. When you truly understand how to structure your answers for these complex multi-stage problems, you're not just solving a math equation, you're building a structural masterpiece. Every paragraph, every line of working becomes a masterpiece that examiners literally can't help but award full marks to. Let's get into it.
So, let's start with the elephant in the room. Why do multi-stage analysis questions cost students so many marks? It's a vital question to ask ourselves right off the bat. The sheer difficulty of multi-stage analysis in topics like composite functions often catches candidates completely off guard. You know the scenario. Some students overload their answers with raw math facts but zero actual analysis, while others just rush and completely miss the command word requirements. But here's the undeniable truth. The concept of the domain of g of f and the range of g of f appears in practically every single examination series. It is unavoidable. You can't just cross your fingers and hope it won't show up. It will. But instead of seeing this as a threat, we're going to view it as a guaranteed opportunity. This is your chance to secure high marks by understanding exactly what the principal examiners are looking for when they've got that red pen in hand.
Here's our quick roadmap for today's session. We're going to break down the challenge of the exam structure itself, establish the core principles you need, walk through a precise technical methodology, reveal the top examiner traps so you don't fall into them, and finally, elevate your skills to critical mastery.
Okay, Section 1, the challenge, securing the method marks.
When you're sitting in that exam hall, the real battle isn't actually just finding the final numerical answer. The Cambridge assessment framework heavily prioritizes analytical depth over superficial breadth. This is a massive mindset shift you need to make right now. A lot of candidates try to memorize a wide, superficial breadth of mathematical facts without understanding how they truly connect. But Cambridge is designed to penalize exactly that approach. Top-performing students show a deeply connected conceptual understanding that they can transfer to totally unfamiliar contexts. You need deep, logical, and structured reasoning. The exam is testing your fundamental knowledge, your ability to apply it, and your capacity to actually analyze it step by step. Before we continue to the absolute core of this strategy, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's look at this direct quote straight from the grading authorities. Candidates referencing cross-topic connections achieve significantly higher marks. The theoretical architecture of composite functions doesn't exist in a vacuum, guys. It relies on precise definitions, causal relationships, and integration with other areas of your syllabus. When you show the examiner that you understand how the domain and range of a function connect to algebra, to graphing, or to calculus concepts, you immediately elevate your answer from a standard, average response to an exceptional one.
Moving on to Section 2, let's get into the technical methodology, specifically our 5-step blueprint. Before we hit the steps, we absolutely must define our core constraint. The domain of the composite function g of f must be a subset of the domain of the inner function f. This is where so many marks are lost. To make this intuitive, I want you to think of a composite function like a 2-step factory assembly line. The raw materials, your input numbers, going into the second machine, which is function g, are strictly limited by what the first machine, function f, can actually process and output. Right? You can't feed a part into machine 2 if machine 1 couldn't even build it in the first place. Similarly, the range of g of f is a subset of the range of g. Principal examiners consistently flag that candidates confuse this terminology. You have to define your terms and understand these constraints before you start throwing numbers around on the page. So here is the exact standardized sequence to tackle these problems. Step 1, deconstruct the question, decode the command words. Step 2, extract the relevant data, pulling out the specific functions and constraints. Step 3, select your analytical framework. Step 4, and honestly, I cannot stress this enough, execute with crystal clear notation. And Step 5, present with correct terminology. Approaching the problem this way develops the exact professional skills the examiners are testing for.
Notice the crucial shift in focus during your actual working phase here. First, you identify the key elements. Then, apply the relevant principles, like that factory assembly line subset rule we just talked about. From there, you execute your analysis with clear working. Then comes Step 4, which is a total game changer. Verify your results.
Never, ever skip verifying that your resulting domain and range actually make mathematical sense in the real world. Finally, check your presentation format. Proper formatting is the bow that ties your beautifully constructed answer together. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's move into examiner warnings and how to avoid the traps.
Even the best mathematical structures can collapse if you don't know where the sinkholes are. This right here is exclusive insider knowledge, pulled directly from principal examiner reports. These are the top 3 specific mistakes that cost students their method marks. Number 1, using the wrong approach for the context. The classic trap in composite functions is blindly applying a general algebraic rule without looking at the specific domain constraints you were actually given. Number 2, forgetting to check format and presentation. A brilliant mathematical mind will still lose marks if the examiner cannot read or logically follow the notation. And number 3, providing answers not specific to the given context. For example, if a question limits a domain to strictly positive integers and your final range somehow includes negative outputs, you haven't paid attention to the context. Avoid these systematically and your marks will automatically rise.
Let's shift gears to the final tier of understanding: mastering critical analysis, evaluating, and problem solving. Getting the right answer shows basic competence, sure, but higher-order assessment objectives demand that you can evaluate, compare, and provide justified recommendations. When a question asks you to evaluate or compare mathematical approaches, you need a highly structured response. Look at this breakdown. For similarities, you must identify shared traits and provide hard evidence. For differences, you must contrast features, again with clear evidence. Top-tier comparative analysis requires addressing both sides of the coin. And your conclusion? It has to speak to the relative importance of these factors, supported by justified proof. Use comparative connectives in your explanations to show the examiner you are actively weighing the mathematical options.
For comprehensive problem solving, we use this clear, deconstruct, solve, evaluate method. Identify the given info, break the problem into logical steps, and solve systematically. But pay special attention to step 4 here. Check for reasonableness. It's so critical. If your calculated domain for a real-world physical measurement turns out to be a negative number, your result is not reasonable. You literally cannot have a negative length. You must catch that contradiction yourself before you draw your final conclusions and make those justified recommendations.
True critical mastery means actively hunting for limitations in the evidence or the mathematical model itself. What assumptions were made when defining the initial function f or g? Are there alternative interpretations of the data? Understanding exactly how these limitations affect your mathematical conclusions is exactly what separates a genuinely outstanding, top percentile student from the rest of the pack. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. I'll leave you with this final provocative thought. Are you taking the time to define your terms and mathematically check your assumptions, or are you just rushing to calculate a final answer? Remember, the method is the mastery. Applying this architectural blueprint to your next past paper won't just change how you study. It will fundamentally change how examiners grade your work. Keep practicing your structured analysis and keep building your mathematical foundations step by step.